Yeah, I'm going to record this. I don't know if it gave you guys a notice, but there are a few people who asked me to record it for them. So Christian can hear me. Who can hear me or not hear me? If you can hear me, just go ahead and type in the chat box and just let me know that you can hear me. Perfect. Oh, I see. Hold on, Dave. If I take this out, is this better now? I went from like my headphone microphone to the regular microphone. Okay, perfect. That works. If you can't hear me at any point, just put it in the chat and I'll try to answer it. If you have questions, throw them in the chat and I'll try to answer it. Unfortunately, I've muted everyone because all it really takes is one person having their mic open and then nobody can hear anything. So let's go ahead and get started. I really appreciate you guys taking some time out of your day to come and listen to what I have to say. Hopefully, you will find it very valuable. So I titled this presentation, Managing Large-Scale Application Development. And as you'll see when we go on, it's basically a repeat of a presentation that I made at NI Week several years ago. This is the first in a series of webinars, so I plan on hosting one roughly, for this year at least, every other month, because it kind of works out with my conference schedule and everything. Most of the presentations are going to be presentations that I've already done, but I'll redo them so that you can ask me questions. And then also I'll have some new perspective because, for example, this presentation I did 5 years ago, so my perspective has changed a bit since then. All right, so that's a picture of me in case you don't know what I look like. If you follow me on LinkedIn or the NI forums or any of those places, I have a whole bunch of 3-letter acronyms after my name, CLA, CPI, all kinds of other stuff. Those are all good, but basically what it all boils down to for me is that simply making it work isn't good enough. I assume some of you guys probably saw Jim Bing had a post he put up recently where he had a huge widescreen monitor full of spaghetti code. And the sad thing about that is that spaghetti code probably worked. I say worked in quotation marks, because it probably had some quirks and bugs. But I know I've seen code that looks like that actually works. And in the presentation later, I'll show you an example of that. And those people in their mind were simply trying to make it work. Right? And anybody can make it work. But the real art and mastery and craftsmanship in writing LabVIEW code is writing stuff that's both reliable and maintainable. And you know, when you saw that spaghetti code, if you're like me, you probably cringed because you know that at some point somebody has to go in and maintain that code, and it's not easy. All right, so here's some things I like to think about. So learning equals change. So if you read a great book and then you put it down and nothing in your life changes, you didn't really learn much from that book. Right? So I'm going to present you with a bunch of information here, and hopefully at the end of this, something about at least the way you see the world will change. And it starts in your mind. We tend to think about change as in like the end actions, right? Oh, I use source code control now, or I do this now, or I do this differently. And that's all good, but it really starts in your mind, and we have to change our mindset from making it work to writing reliable and maintainable code. And it's subtle, but it's a big difference. And that will then drive actions that you take. When you're just trying to make it work, it's okay to produce spaghetti code because it doesn't matter. But when you're thinking long-term about writing reliable, maintainable code, and we'll avoid that spaghetti code now because we know that's not reliable and maintainable. So my challenge to all of you listening is, as you go through this, pick one or two things, and they can be really small things, to change about the way that you do things, right? And try to approach things from this idea of, I'm not just trying to make it work, I'm trying to write reliable, maintainable code. And I know several of you people on here, so I know a bunch of you guys have already made this mindset shift, but if you haven't, it's definitely something that will help you out a lot in the long run. And, you know, we all start out with the making it work because, you know, if you're like me, I started out as an engineer. I got thrown, you know, DMM and LabVIEW on my desk and said, here, take these measurements and automate it, right? And my boss didn't say anything about writing reliable, maintainable code. I didn't really think about what was going to happen 5 years from now. But I can tell you, I've worked on systems that have lifespans of like 15, 20 years, and they need to be reliable, maintainable, right? I mean, systems that started out on Windows XP, and we had to migrate them all the way up to Windows 10 because they stopped support on Windows XP, right? So, you know, having code that's reliable and maintainable really makes that easy, and hardware goes obsolete and all kinds of things happen. So that's kind of the basis for where I'm going with this presentation. Hopefully that set the stage. Again, if you have questions, feel free to ask in the chat box. I will try to check it periodically. Okay, so we're going to go into the slides from my original presentation. I tried to leave everything pretty much the same. I added a few slides. I kind of noted where I added stuff. This is a presentation that my friend and colleague Eric Simon and I presented at an iWeek back in 2013. So it's 5 years old. His title says CLD there. He's actually a CLA now. But at the time, he was a CLD. And it's called Managing Large-Scale Application Development. And as we get through it, you'll see why it's called that. Okay, so this is just an introduction slide to kind of talk a little bit about some of the things that we were doing at Westinghouse, some background. So some of you guys might think of Westinghouse as this big company that does, you know, all this different stuff. By the time I started working for them, they had sold all that off and they're just making nuclear power plants. And so we did a variety of projects. Vibration monitoring. Nuclear reactor vibrates at a certain frequency. If that changes, that means that something's wrong. So we were monitoring that and sounding alarms. Loose parts monitoring. Sometimes parts break loose and rattle around in the reactor. Or more commonly, when they do maintenance, people drop wrenches or screwdrivers or something in there, and it rattles around. And basically, they have to determine what it is, where it is, and if it's going to cause a problem or not. If it's going to cause a problem, they have to shut down, but if not, that's pretty costly, so they'd rather avoid that. And so we had microphones throughout the plant, and we would triangulate the locations of the various objects that were loose and rattling around, and then try to tell them what it was and make some predictions based on that. Mapping is just driving detectors up inside the reactor and then taking readings, looking for hot spots, which are bad. And then plant startup testing and qualification. I don't know how many of you guys know, but back before Fukushima, there was this thing called the nuclear renaissance. They were building new plants. And they put everything in place, and then when they started up, it's called a pressurized water reactor, so it's got really hot, super pressurized water running through it. And if you're a mechanical person, you know that when things get hot, they expand. And so the pipes all expand and move. And so we had a bunch of compact Rios, like on the order of like 100 or something, spread out throughout the plant with various sensors to measure parameters on all these pipes, to measure the slope and various things that needed to be verified to make sure that they hadn't moved too much so that they were still in spec. Leakage monitoring, we would take throughout the plant and sample humidity at various points, relative humidity, and if one spot suddenly shot up, then that meant that there was possibly a leak there. And circuit board testing. So a lot of nuclear power plants, when they were built in the 50s and 60s. They didn't have PLCs, they didn't have, so their control systems were basically a series of circuit boards in a back. And so if you know much about old through-hole components, they degrade over time. So we had this circuit board tester that we would go to the plant, they'd shut it down, pull out all the cards, and one at a time we test them to detect any problems. And we used a whole wide variety of hardware and software stuff. I mostly did PXI stuff. My buddy Eric did a lot of CREO and FPGA stuff. That's just overall what we were doing at Westinghouse. So this presentation is really broken into 3 parts. There's the transition, which kind of explains how our work environment underwent this drastic change. And then there's a section on process improvements. So basically all the problems we ran into, how did we address them? What did we do to counter some of those issues? And then there's a section at the end. I gave this at NI Week, so I talked about leveraging NI and how all the things that NI does that could help us. And since this is my webinar today, we'll also talk a little bit about System Automation Solutions, which is the company that I run, and how we can help you and how you can use us as a resource. Anybody have any questions so far? If you do, feel free to throw it in the chat. It's nice to see a question occasionally. That means that people are actually paying attention and haven't tuned me out and started checking their email. All right, so when I started, I replaced this guy, and he was the lone developer pretty much in all of Westinghouse. And I worked in the research and technology department, which is like this centralized location, and we did projects for other parts of the company. And so I inherited the circuit board tester and a few other things. And my buddy Eric got hired in the other group, and the guy that I replaced had done some projects for them, so Eric inherited those. And so both of us were single developers. We kind of got thrown to the wolves. We're working on, so small to medium, but they're actually medium to large size applications. And minimal requirement, and that might seem kind of odd if you're not nuclear space, but what happens is the NRC says that anything that is safety critical in a nuclear reactor has tons of process involved in how you write software for it, and it's super overkill. So then as soon as a project comes up and they say, oh, it's not safety qualified, then it's kind of like free for all, because nobody wants, everybody's like, woohoo, whippy, we have no requirements, so they go the exact opposite way. And I'm sure most of the people here would probably agree that somewhere in the middle is the right amount, right? You need enough process to prevent chaos, but you don't want so much process that you can't ever get anything done. So what happened was we went from lone developers. I started helping Eric and I started working together, and he actually worked in a separate building, not a couple miles down the road. And then at some point, Westinghouse bought this other company in Connecticut, and we were located around Pittsburgh. And so we had this geographically separate team, and we went from just the 2 of us to now there were like 6 or 7 of us. And Westinghouse finally came to its senses a little bit and said, hey, all this stuff that's not safety related, we still have to have some process control and some formal documentation process. My guess is they probably got burned on some project, and so they implemented all these in-process requirements. And it became very formal. And so part of the challenge is trying to fit together how do we work with these people in different areas, and how do we keep from stepping on each other's toes and coordinated and all that stuff. And we started working on larger and larger applications. So we started working on that plant, the new plant stuff at, several 100 CREOs, and they all had to talk to each other and they all had to be coordinated. So the applications got more complex, and we went to more team-based development. Whereas like the other projects, yeah, we kind of worked together, but basically one of us was working on it. We did the old subversion model. One person checks it out and does it, and then checks it back in, and we weren't really working in parallel. So that also had to change a little bit. So here's the spaghetti code that I promised you. The one that Jim King had was much worse than this. But you'll notice this is frame 17 out of 18. And you need 18 frames because the first 16 initialize all the global variables in the correct order to avoid race conditions. And you can see some of the global variables are sprinkled around in there. And in the guy's defense, at least a little bit, it was written in like LabVIEW 4 or 5 originally, so that's why it's doing the polling on the left side instead of doing an event structure. I see some chat stuff. Okay. Oh, Kevin's got a very good question. My biggest answer to that would be start small, implement what you can. So for example, I talked to somebody, they were working in this mill aerospace company. And by the way, questions like this are great, so keep them coming if you have more. But I talked to somebody, and Brian actually might be on this call, and he was talking about how, yeah, I'm working on this machine and it's not allowed to be connected to the network or anything. I don't know what to do. And he started using Git locally and making local checkouts and stuff. And so, yeah, that's not ideal. It'd be nice to have a centralized server and run all kinds of stuff on it. But start as small as you can and do things that work. And I think as you start to do these small things and the management starts to see the payoff, right? Because your productivity will go way up in the long run. Right? If you're doing things the right way, you're going to outperform all the other groups that are doing LabVIEW, and somebody at some point will notice. Does that answer your question? Kind of helpful? I mean, that's the best answer I can give, because trying to get management to buy into this, and I think I have a slide about this, it's not their fault. They're not programmers. They don't understand the value of these things, and they tend to have a short-term mindset. So really, you just need to try to do things the best that you can. And if you're outperforming everybody else, eventually they'll come to you and be like, hey, why are you outperforming these other people? And then you tell them, and hopefully the other people will want to get on board with that too. All right, that was a very good question. Sorry, we might get sidetracked again. Yes, localized user groups are awesome. That's a great idea. And try to get everybody on the same page and reuse code too. We had one at Westinghouse, and I think we'll talk about it here in the slides a bit. But yeah, we started one, and we started a reuse group, a reuse code that we distributed to people, and it really helped a lot. All right, I'm going to move on, but throw some more stuff in there if you have more questions, and if you need more clarification, Kevin, we can talk later. All right, so here are some of the problems that we ran into. When I started, and this was probably like 2007, they were not using source code control at all. They were using zip files. And they had terrible cross-linking issues. Some of you older LabVIEW developers probably remember cross-linking issues. If you're doing things right nowadays, you really shouldn't run into them, but they still happen. Poor configuration control. We had all these circuit board testers, and they had written like a scripting language where you could type in a text document and some commands, and it would run them. But they had no control over them, and people would change them in the field, and then you have 5 machines, and they'd each have a different sequence on it. Nobody knew which one was the correct one. So the configuration control went way beyond just source code control, just configuration control of everything. For example, the circuit board testers, they had issues where they didn't have really good wiring diagrams, and it just said, oh, connect this to ground, and one person connected it directly, and one connected it way around, went around in like 3 circles and plugged it in somewhere else, and it just made troubleshooting really hard. No real bug tracking. The guy that I replaced had it all in his head, didn't even really have an Excel spreadsheet. So if you're not tracking bugs, at least do an Excel spreadsheet. I've talked to some people who are doing that because, they can't get IT support to set up like a Bugzilla or Redmine server or something. But some process is definitely better than none in these areas. And there is no real build, versioning, or release scheme for managing that type of activities. So some other problems we ran into, poor requirements handling and tracking. No well-defined design phase, right? So we get a problem, and since there's just a single developer, they just throw themselves at it and start writing code, and not really have a plan. As an example, we inherited this project, and the guy had been working on it for like a year, and and it was this big, huge, colossal monstrosity. And I sent him an email. I said, hey, you've been working on this for a year. Do you have any design documents, like anything that describes what's going on? And his answer is basically no. And so he did a lot of rapid prototyping, and then the prototype became the final product, and we just code and fix. We also had a lot of monolithic code and little code reuse. As an example, the screen that I showed you earlier, the spaghetti code, that circuit board tester had a 3-axis motion controller to move a probe around to probe different points on the board. And we started another project that needed 3-axis motion control. And my boss was like, oh yeah, quick and easy, we'll just grab the code out of the circuit board tester and put it in there. Well, there were all kinds of global variables and flags and stuff that went along with that to pull it out to put it in there. And, everything broke and it was a mess, and we ended up not reusing that. Whereas if we'd had thought a little bit more about making our code more modular and reusable, we could have pulled that out and saved a bunch of development time. So some of the process improvements, this says current state. This is at the time that this presentation is given. I should also let you guys know that not long after this whole presentation, I quit Westinghouse. So I still talk to some people there. I have some insights into where they are today, but I don't work there anymore. I haven't worked there for a while. But if you compare this block diagram down here to the one on the previous slide of the spaghetti code, it's much easier to get an idea of what's going on here. And we did that by having some informal style guidelines. We all read the Blue Me style book and just kind of agreed. We didn't formally write it down, but we're like, okay, we're going to try to follow this. We started doing peer reviews where we actually looked at each other's code and would ask each other questions and to help for things. And we started getting certified. So Westinghouse went from having nobody who was certified to at one point they had 5 or 6 CLAs and a couple CLDs. I think a couple CLADs as well. And you can see some of our reusable components here as well. For the, I don't know if you guys can see my, but in the initialize frame, that bottom right hand, that's a error handler. And then inside the event structure, the X in the green. I will answer your question in 1 second. The red X in the green, that's for deferring front panel updates. So we created some reusable code there. All right, let me look at Christian's question. That is a very, very interesting question, Christian. And I have to say my gut reaction is usually to try to throw it away. I find a very good thing to do is ask them if it works. Right? If they have spaghetti code and it does not work at all, there is no redeeming value, and I just throw it away. They say, that's just me. If it works, it gets trickier because then you're telling them that they have to spend all this money to fix something that in their mind isn't broken. And so that's much harder to sell. Yes, exactly. Yeah, and if you talk to them, they'll say it works, and then they'll be like, but there's this bug, and sometimes it does this weird thing, and occasionally, you have to restart it, and so works is in quotes for a very good reason. So there's that. If you talk to people like Fabiola is really big on refactoring code like that, and she talks about finding the meatballs in the spaghetti, which is basically just go and find stuff that you can make into a module and make it into either, in her case, a DQMH module or whatever you like. I have done the take it and just keep rearranging it until it looks pretty, and that takes a lot of effort. So Luis, uncertainty. My best thing for uncertainty is find Steve Watts did a presentation on uncertainty. It's on YouTube. You should watch it. It's about, there's a book called Dancing with Bears, I think it's called, or Waltzing with Bears. And he does a review of it and talks about uncertainty and how to manage it. The hardest thing is to get the requirements down, right? So most people they think they know the requirements, but they really don't. I'm sure everybody's laughing when I say that because we've all run into it. What I've tried to do to help deal with that, Luis, lately is I try to break stuff down into, if I can think of it in terms of modules, like as an example, I have a project right now coming up and they want to use decaf, which is really nice because it's super modular, and they're controlling a pressure vessel. So first, so I'm kind of breaking it down kind of like an agile process. So like the first stage would be install decaf, get it set up, get a PID module set up to read the temperature and control it. And it's controlling via heater, so it's set up like a pulse width modulation module for the heater. And that would pretty much be it. PID, you set the set point, there's the heater, you get a graph. And then I would add on, okay, well, to do alarming, then we'll add an alarming module. To do, this or logging to disk, we'll add a logging module. And so then when you break it down like that, it's a lot easier to estimate the smaller chunks. And it's also difficult to do that type of estimating when you've already got a big, huge mess, right? And it's a giant mess and you're trying to just pick out pieces of it. That's a lot harder. So I don't know if I answered your questions, Christian and Luis, a little bit. Maybe. All right, I'm going to move on because I'd like to try to get through this slide. But yes, definitely watch that. And Chris and Steve gives them scores. So he has like a matrix where he gives stuff scores. And at some point, he just says, either I'm not going to do it or there's no way I'm doing it fixed price. We're doing it hourly. So that's one way to mitigate risk. Because if you do it hourly and it takes you longer than you expect, you're still getting paid. So, all right. So some of the things that we started doing to counter some of the problems that we had, we started using Subversion for source code control. I think you'll find nowadays most people have moved to Git, but back then Subversion was the thing to use. So we started using Subversion. And we started using something for bug tracking called Bugzilla, which I think is still around. It's from Mozilla. But you can use Redmine, you can use Jira, you can use GitLab. There's all kinds of different bug tracking things out there. One of the problems we ran into was that even with a bug tracking system, it's not enough to just put them in there. You have to have some sort of process for moving them out of the queue and into developers. Because what would happen is one person would enter a bug and assign it to a developer, one of the engineers, and the developer would go do it. And the next engineer would look at the final product and say, that's not right. And he'd put in a bug to change it back. And we'd go back and forth. So we implemented this thing. We called it a change control. We meant that any new bugs that got put into the tracker got assigned to this change control board, and then they would put them all on a spreadsheet and decide how much time we had available and resources, and then they would pick and choose which ones got worked on and who worked on what. We started doing really much more formal. They weren't like super formal, but software design documents where we draw UML. We started using a lot more class-based stuff, so we draw UML class diagrams. We would, write out, before we started coding, we would write out the API for the different modules and how they communicated. And we implemented a very formal build, versioning, and release scheme for how we released different versions of software. Sorry if I'm talking fast. I kind of want to try to get through as many of these slides as I can. If I go fast and we have time at the end, that would be perfect because then we can ask a lot of questions and go around. So, some of the other stuff that we started doing, we started using a program called Boars for requirements tracking. That I don't know much about. That was mostly my buddy Eric who did a lot of that. But it was a formal requirements tracking process. I imagine it's somewhat similar to maybe Requirements Gateway. So we started doing this agile approach, but before we started coding at all, we would do this design phase where we sat down and we laid out the major modules. And then we would go back and update that as we kind of clarified what we were doing. So in the beginning, it would just say, oh, here are 4 or 5 modules, here's how they communicate, and that's it. And then when we would start working on those modules, then we would go back and fill in our design document. So when one of our sprints was to work on the error logger, then we'd say, okay, well, here's exactly what the error logger has to be able to do, and blah, 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 and fill in all the details. And we started doing weekly Scrum meetings, which we really weren't doing much of anything before communicating at all. And so we just made very heavy uses of classes in the libraries. And one of the main reasons to do that, as I'm sure some of you guys are aware, is if you're using source code control, if you're working in different libraries, and the APIs are really well defined, you can work in parallel and not step on each other's toes. So that's the big thing. And we made a lot of reuse libraries in some frameworks that we built up. And another thing that we did that really helped out was setting standardized hardware. So one problem is, you know, if you've got 4 or 5 projects, they all use a DMM. If they all use the same DMM, you can have like 1 or 2 spare DMMs, and you can cover it. If they all use a different DMM, then you need a different spare DMM for each project. The other place we saved a lot with the standardized hardware is that a lot of our stuff would go in these 19-inch racks, and people would use different size monitors, different keyboard layouts, different power supply layouts, all kinds of stuff. And we ended up spending a lot of time doing mechanical drawings on just how to mount stuff. And so now, you know, having a standard for that, it helped out a lot there. And one thing I would say, and they didn't have this when we were doing it, but MI has like their ATE core configurations or something. I don't know if anybody's used those. I'll comment, I'll check that in a minute. But the AT core configuration is basically a 19-inch rack mount on wheels, and it's got a power plug, power supplies mounted at a specific spot, fans, and some other stuff. And it's already all mounted. It's got an emergency stop button, and it's got power supplies built in. So it'll definitely save you a lot of time and a lot of hours in engineering drawings to how to mount, excuse me, all that stuff. So you like Tors, Luis. That's awesome. I've never used it. Version numbers. Okay. Okay, so let me take these one at a time. Version numbers, right? So there's major, minor, rev, or major, minor, bug fix, and build, I think. There's a standard for that. And if you look it up online, semantic versioning or something like that, I think. I don't know who viewer 15 is, but yeah. So look up semantic versioning, and that will help you. And then also the very last one, what we would do instead of putting a build number, and I think my presentation goes into that, we would try to pull the SVN rev number and put that there so that then we could, if we knew exactly what build it was, then we could pull that out of Subversion and just check it right out. Yes. Yeah, there are some issues with that we ran into, and we'll talk about that in a little bit, but that is definitely the way to go. All right, there's some other. How to resolve reuse toolkits for different versions of LabVIEW. There are a lot of different thoughts on that. My thought, what we started doing was using VIPM. So you find the oldest version that's common to all the projects you want to use it in, write it in that, if you can, and then make it a VIPM package, and then when they install the VIPM package, it will automatically upgrade to the correct version. And part of that is, the way I like to do it is one person's in charge of that package, and when it gets installed, I have a script that makes it read-only, so nobody can modify any of that. And if you need to make changes to the reuse component, you tell the guy who's responsible for it what changes need. They go through the whole build process and then release again. And then you use the new release. Is that okay? Yeah. Yeah, I'm a huge fan of VIPM. I'm not sure NIPM and the new NXG stuff I'm not super up on. So, all right, how often do you perform a software sprint review? I think that really depends on the size of your project, and also like how many projects you're working on at once. So like if you're just working on one project and everybody in your team's like on one project, I think every week is great for reviews. If you've got developers who are working half time on your project, half time on another project, meeting every week might not make that much sense because it depends on how much work they can get done in between. So have I answered everybody's question? Anybody still have a question? All right. All right, so let's move on to the next slide. Okay, so some of the headaches we ran into, as Kevin mentioned, differing LabVIEW versions for reuse. That's a problem. Replacing LLBs with LV Libs. So I don't know if any of you guys remember LLBs. If you've been around for a while, you might. So basically, an LLB was basically a zip file with some LabVIEW VIs inside it. And that was how you distributed chunks of code. You give them one file that's an LLB, and it's got a bunch of VIs inside that they can use. The problem with source code control is that if you put one VI in there, it marks the whole LLB as revved, and so it's very hard to track stuff. So we started replacing all those old LLBs with LV Libs. The other issues we had were merging project, library, and class files. Basically, my one-word answer to that is don't. Don't try not to work on the same library, project, or class files. Supposedly they're XML, but they're not really XML. There's some binary stuff in there, and they will get corrupted and cause you no end of heartaches. So basically, it kind of goes back to when, in VIPM, when we talk about reuse, one person who's in charge of that particular reuse module. In a project, I have one person who's in charge of every class or set of classes or libraries or something. And then, very carefully not to step on each other's toes. Putting SVN revision numbers in software builds. Basically, what would happen is, check it out. You go to make your build, and you're at version 15, right? It's the SVN version right now. And then you pull that out. You update your number in your build, and you run your build script. Okay, great. You just built version 15. That's fine. You go to check it back in. Hey, if you checked out version 15 and you check it back in, now it's version 16. But the other problem is you don't know what version it's going to be because somebody else could have checked something else in the meantime. Yes, absolutely, Kevin. I always try to separate it. It makes checking in and out a lot better. So I personally always separate compiled code. Yes, it's the default. Yeah, it is difficult to use. If you go into project settings, I think there's a project setting that says all new VIs in this project, mark them as separate compiled code. And I think it pulls up a table and lets you change them all in bulk too. So yeah, it's not as hard as it used to be. One thing I will mention is sometimes when you do that, you have to clear the compiled object cache or something, because sometimes things get messed up when you change that. Although that's getting better and better as LabVIEW goes on, it's getting more and more stable. So, all right. Yes, so yeah, that definitely scripting for builds is really useful, Kevin. The problem we ran into, like I said, was you check out version 15, you think, well, when I check it back in, it's going to be version 16, but then somebody else checks something in between, and now when you check it back in, it's version 17. And so there's a little bit of handshaking that has to go on. All right, so some of the future plans that we had at the time, and this was 5 years ago, one of them was to start a company-wide LabVIEW users group, which we did, and it went on for a while. And then eventually the culture changed at the company. We didn't get as much management buy-in. They started, in my mind, mistreating people, and a lot of the good people left. And the people who were driving the LabVIEW users group left, and it kind of fell apart. But it did work for a while. So my thing to you, Kevin, if you're trying to start a LabVIEW, company-wide LabVIEW users group, is get management buy-in as much as you can, as high up the food chain as you can. And try to have multiple people driving it too, so that if one of them leaves, the whole thing doesn't fall apart. We had coding standard to that. Peer reviews we didn't really end up doing. The training and certification thing, we did a lot of that. Yes, the Bloomy book is really great. I want to say it's been a while since I read it, but I don't think it includes object-oriented, which I find is a little disappointing because I think it came out before object-oriented was really an official supported thing. So, but yes, it is very good. In fact, I had a copy when I worked at Westinghouse, and I couldn't find, when I left, it got left there. And I just bought another copy, but they're really hard to find and they're expensive. But if you go, I bought mine on eBay, I think. Digital copies probably a lot easier to get. I like hard copy books. Maybe I'm old school. All right. More formal documentation and definition on process. Standardized design documentation. We started doing more UML because we were doing more group-based stuff. We automated adding the SVN res to the build, so we wrote a little script to do that, like Kevin suggested. And for versioning control of reuse libraries, we use BIPM. And that was our reuse library framework. All right, so new materials. So this is some lessons learned this is a slide that I added now 5 years later. So I picked out really 3 keys. Number 1, it's about having a process. And you have a process right now, whether you realize it or not. Right? But if you write it down, then it's repeatable, right? So write down what you're doing, and just the act of having it written down has a lot of value. And it doesn't really matter. There are 50 or 60 people on this call. We all probably have a different process, but the key is having it and knowing what it is and writing it down. The other key is management buy-in. Right? You have to somehow convince your managers that taking the time to do it right is worth it. Because in the short term, not going to lie, it costs to do it the right way. But if you look at the long-term picture, you get way better results, way more reliable, maintainable code. And in the long term, right, you might spend more money now, but 6 months or a year from now, your peers are going to be looking at you and be like, well, how did you make that change so easily? Why is your code so robust and doesn't have all these errors? And why is it all, behaving in mine? I've got all these race conditions that are causing me problems. And then another thing I think is key is get outside eyes and outside help. So get other people to look at your code, right? And it doesn't have to be outside your organization. It could just be like the guy sitting next to you. I'm a big believer in bringing in people from the outside because you have a culture where you work and they make certain assumptions and you get this, well, this is the way we've always done it, right? And people can sometimes be closed-minded. And if you bring in somebody from the outside and they look at it with fresh eyes, they'll see things that everybody else is missing. So I think if you do those 3 things, I think those are really useful. Yes, peer code reviews are awesome. And sometimes it's like not even having sometimes it's just sitting and explaining your code to somebody else when you talk through it. We all have this thing when we're taking like letters and stuff that our mind works faster than our hands and we get ahead of ourselves. So yeah, aha moments. I don't know how many times I've tried to explain a bug to somebody, and as I'm explaining to it, half the time I'm like, I don't really need you anymore. I already figured it out. It's like, aha, that's so. All right. So here's the section on leveraging NI. I'm going to flash this because I assume most of you guys already know that NI is available to help you guys. Their website, I wish I could say it's gotten better over the past 5 years. It's still hard to navigate, but you can get hardware specs and manuals on there. Googling error codes. The search on the NI website is not that great. So if you're having trouble finding stuff with the NI search, go to Google and just search on Google and it'll direct you back there and find stuff quicker. But error codes, you get a weird error, you type in the error code and it pops up, and literally within a couple of hits I can figure out what's causing the error and how to solve it. Forums for common questions, there's all kinds of forums. There's also the Lava forums, which are also very good. Not NI, but very useful. Examples in reference code, there's tons of them on there. White papers, knowledge base, and user groups. There's a LabVIEW Architects Forum, maybe, that Fabiola runs, that runs out of Austin, and they webcast it, and it's very good. Software subscription program. If you have any kind of ongoing license, you're the SSP, and you get service requests, access to online training, which I think they've expanded, and you can do a lot just through online training now. So leveraging your local NI sales rep. Some of you may be laughing because we used to have local sales reps. This we did, and they were very good. This is our local sales rep in Pittsburgh at the time, Ishmael. I don't know if any of you guys met him, but he's a good guy. But they could do all kinds of stuff for you. Now the sales structure has changed, and if you don't know who your sales guy is, go to this website, us.ni.com/contacts, and it'll tell you. Some of you guys are not in the U.S. I don't know what the deal is in other countries. I don't know how they've done it. But it used to be local sales guy, and he'd come visit and talk to you and stuff. And now you really have to get that if you're a big company, big client. Yes. So as they moved, so Kevin, they moved the local sales rep. Now they're in Austin. So a local sales rep, they cover a much larger area. You know, you're not going to sit down and have lunch with them, but you can call them on the phone. And you know, mine has been pretty good. So I miss having the local person, but you know, you can still make it work, and they're still there to help you. And they want to sell you stuff. So that's my thing. I don't know if any of you guys are new to NI, but NI makes their money off of hardware, not software. So if you can make the case to them that you're going to buy a lot of hardware off of them, you will get moved up the chain of support stuff pretty quickly. So that always helps. So if you're on a project that's going to buy 4 or 5 Pixie chassis from them, and you call support, make sure you tell them that, and they will definitely elevate it. And case in point, we had a project where we were going to buy several Pixie chassis, and it was a real-time project. And at the time, I did not have much experience on real-time. Okay, somebody mentioned the sales rep for St. Louis. Very cool. So, yeah, we had this thing, and if you look inside the graphic of the PXI chassis, I don't know how well it shows up on your screen, there's this huge class hierarchy, and it's a mess. And what happened was we could build it. Well, we ran it on our test system, and we ran it through the LabVIEW interface, and everything worked fine. And then we built an RT executable, and it would build, but when we tried to deploy it, it wouldn't run, it would crash. And so we tried a whole bunch of support stuff, and basically the whole thing ended up in me getting a free trip down to NI, and I sat there next to one of the NI R&D guys while they troubleshot and figured out what was wrong. So NI definitely stands behind their products. They will help you. Part of the key is, though, like they've got big resources to help people, so if you can make a business case for them, they're like, hey, we're going to buy a whole bunch of your stuff going into the future, and you're a big fish, that definitely helps. If you're like a one-off consulting shop and you're just doing some software and you're not buying hardware from them, it's a little bit harder to get them to take you seriously. So there's some lessons learned here. One, manage dependencies carefully. You could see from that class hierarchy diagram, everything is linked to everything. That's bad. Don't want that. RT programming is not the same as Windows. That should be a no-brainer, but you know, my boss, I wanted to take the RT class, and they decided they couldn't fit in the schedule, so we took the RT class after we finished the project, which didn't really make a lot of sense. The one thing I will say is build early, build often. Okay? So if we had built this, we waited to build it to literally like a week before we were going to test the system and then ship it out. So that was a really bad problem. We could have found this problem a lot sooner if they tried to build it before then. And then if you're going to build early and build often, right, if it's a manual step that you repeat all the time, you should try to automate it. And continuous integration seems to be all the rage right now. And if you can figure out how to work that into a continuous integration process so that you check it in, and it either every time you check it in or nightly or weekly or monthly or whatever, it builds it for you and tests it, that's really awesome because then you don't have to remember to do it. Oops. So training and certification, you guys probably all know NI has a bunch of training courses. They used to have a training and certification membership. So if you work for a company and they don't want to pay for you to get certified, maybe they'll buy a training and certification membership, which includes free certifications, and then you can go get certified. That's what I did. My boss had zero interest in me getting certified, but he wanted me to take all the classes, so I got them to pay for that. So it's a nice little perk. There's a whole bunch of NI events, NI Week. They used to do a technical symposium or NI days. The things have been getting less and less lately, but they still do some. The CLA summits, which are still going on. There's an American, European, I think there might be like an Indian or Asian one, and various user groups. So we got about 15 minutes left. So this is something new since the last time I gave this presentation. That is the LabVIEW Center of Excellence. I know a couple of you guys are involved in that. If you go and read through it, and I did this study a few years ago, they realized they had started out doing the certification exams. And they realized there were some companies that had a whole bunch of LabVIEW architects, but weren't really performing as well as they should have. And they realized that a lot of it had to deal with how they worked as a team, how they managed things, some of the processes they had in place. And so the Center of Excellence is kind of like a roadmap for best practices. Yes, I see a question. I want to say that it's managed by champions. I'm not entirely sure. I do know that a lot of the champions, when they give presentations at various CLA summits and stuff, they end up on there as resources. Nancy is really the person who's in charge of it. So if you're really interested in that, you should talk to Nancy. But yeah, I'll put it up in there in all the presentations. And there's tons of presentations there. It's all free. Anybody can go look at it. They have a one-page or couple-page form that you can fill out, just like an evaluation of where you are right now. And then they have tons of roadmap type stuff to say, hey, if this is what you're missing, here are the steps to get there. And tons of great content. Yes, tons and tons of PowerPoint. I would say 60 is low. There's probably like 100 or more. And every time they do a CLA summit or a NI week, they're adding to it. So, yeah, if you need resources, that's like the first place to look. And I think they do a really good job of breaking it down and having a roadmap so it's not overwhelming. Because that's one of the things that I picked this up from Fabiola, but like, if you watch this presentation, I talk about all this process stuff. You can't go from 0 process to 100 process overnight, right? You've got to slowly just start implementing one thing after another. The next thing is that after you get a couple of things done, then you build up some momentum, right? You see the part of the trick is trying to get your team to buy into it, right? And so once you do a few little things and they see the value, then they'll want to do more. So that really helps. All right, so this is some new material that I add. So how can you leverage System Automation Solutions, which is the company that I run? We have a blog where we do a lot of blog posts. You may have seen some of those. If you're on LinkedIn, you probably saw the post that I put on LinkedIn. That's basically the main advertising I did for all this. We give a variety of presentations at CLA Summits and NI Week. We have a couple free tools that are available. If you check out our website, they're listed there. APM is a tool for running multiple versions of LabVIEW on the same machine. Don't recommend using that, but at one point that was the way to go, and that tool helps do that. AF Tester for building testers for actor framework actors. It's also a free tool that we have. We do this webinar series. We offer coaching packages, so I'm trying to get some people to sign on for monthly coaching packages where we would go and help you run your scrums or sprint meetings or whatever. And just half-day brainstorming sessions or shorter brainstorming sessions. So if you've got an idea for something, you're like, hey, does this sound crazy or not? That whole outside eyes thing, if you want somebody to look at what you're doing from the outside and just give you a fresh perspective, we do that too. Okay, so wrapping things up, we still got 10 minutes, so you can ask any questions you want. So I've reserved some time in the next week for a free 1-hour discovery session. So if you want to take advantage of that, there's a bit.ly link there. You can go sign up. It's not really, it's more of just a discussion. So I'm going to ask you a bunch of questions about where you are and where you want to go and what's in your way. Give you some ideas on how you can get there. It's not really a sales call. I promise I'm not going to try to bother you about buying stuff. It's more about just kind of a continuation of this discussion. There's a survey. It's only got 4 questions. They're not multiple choice, though. It actually requires you to type. But if you fill those out, that would be really helpful. And I plan on doing a webinar every other month. The next one would be in April. So tentatively, they're going to be the last Wednesday of the month, every other month. So it would be April. Same time. Actually, that's one thing I did not put on the survey. Does the time work for you? So if you want to change the time, write in the survey somewhere, one of those open answer questions. You know, I would prefer a different time. It'd be helpful to know. I tried to pick a time that was kind of around lunchtime for everybody in the US at least, because I thought that would be useful. And the topic for the next one, I did a presentation a while ago comparing the actor framework with DQMH, and I was choosing a framework, so I'm probably going to redo that one. I've got some other ones I can choose from. At the moment, I don't really have a lot of time to produce new content, so kind of recycling stuff. But if there's something that presentation I've given in the past that you'd like to see again, let me know, and we can put it on the schedule. Any questions? I have a question for you guys. Did you find this useful? Was it a good use of your time? And did you pick out anything that you're like, oh yeah, I'm going to change this, or I'm going to do this differently in the future? JKI SMO. All right, so Luis, I have a question for you. Do you use the JKI state machine objects? If you do, then perhaps I could do my presentation and you could add on some comments about the JKI state machine objects and about how it compares. So perhaps we should talk offline. I don't think I have time to learn about the JKI SMO for the next webinar, but if you do, or if you already know, or if you know any of the guys at JKI and talk to them and want them to come on and talk about it, that would also work. Yeah, Jim sent out a thing for a survey, asked, because he had sent out all his marketing stuff about their class, and he sent out a thing asking, you know, why didn't you sign up for the class? And basically my answer was, I've got Actor Framework, I've got DQMH, I've got DCAF. Learning another framework is just too much of an investment. And I'm not really sure what it gives you that Actor Framework or DQMH does not. And there may be something there, but until I get a project that requires me to learn how to use it, I'm probably not going to take his class. It may be really cool, and I may be missing out, but I find I get a lot of mileage out of the Actor Framework and DQMH, so. Yes, VIPM is really, really good. You can do a lot with the free version as far as creating VIPMs for reuse. They do have a paid one, which is really nice because it lets you make package configurations. But especially if you're a small team, I know, Ryan, you work more or less by yourself, so probably a VIPC, being able to build those is probably not worth it for you, but maybe. So thank you guys. I appreciate that you guys took time out of your day to come out here and watch this. I'm sure you guys are all busy. So hopefully I delivered on my end and at least delivered something of value to you guys. Simulating hardware. Oh, that's an interesting question. Part of it depends. So I'm a consultant, so I like to work from home if I can and not be on site. So I spend a lot of time simulating hardware. Depending on what you're simulating, if you just got a data logging task, in Max you can create simulated devices, and they work really well. So that I do all the time. Simulate EMM that talks over serial or something, that's a little bit harder. All right, so viewer 12, I'm not sure who you are, but thank you. Well, I'm glad this turned out well. I'm glad you guys got something useful. Yeah, if you've got some free time the next week and you want to sit and talk, make sure you take advantage of that link. I'll put it back up in case anybody missed it. But SAS-Feb-offer. So I'm really glad you guys liked it. Again, you know, it's all about changing the way you think and just thinking with that long-term mindset, which, I mean, I imagine the fact that you guys even came to this says that you're already thinking that way. But if you're not, that's definitely like the first step. And then the second step is just finding some things to implement and just start moving in that direction. And you'll gain some momentum. Once you do one or two things, it'll be easier to add more on later. All right. Well, I am going to call it a wrap unless anybody has any more questions. Oh, there you go. Yes, there's the survey. And I'll put in the, I should have put it in here because you can't click on it. Oops. 1 second. Bought a new ergonomic keyboard, so it's a little harder to type. I'm not used to it yet. But there's a thing for the scheduling a 1-hour session. So I really look forward to talking to you guys and learning more about all the cool projects you guys are working on. And hopefully I'll see some of you guys again in April. All right, well, I don't see any more questions, so I am going to go. So thank you for your time. I really appreciate it. I know you guys are busy.